So it says, use one application of the trapezoidal rule to approximate. Okay, this. Right. And then it says, use the trapezoidal rule using 5 function values. Let's start with 5 function values first, right? Okay.
Yeah.
All right. So basically what we do is we set up a table of values. And because we're looking for 5 function values, I'll basically cut this up into 6 columns, of which we need a next column and we need a y column, right? And our curve is y is equal to 2 to the power of x. Do not bother trying to integrate that. You can't do it at this stage, right? Don't try to integrate it, right? Just work with this, right? This is, we're dealing with an approximation, right? Now, here's the thing. Where are we starting from? Where are we going to? We're starting at 1, going to 3. So you go 1, 3, and then we choose the halfway point. Where's the halfway point? Well, 2. And then the halfway point again?
1.5.
1.5, and then 2.5. So we start with this, right? If they want 5 function values, we give them 1, 2, 3, 4, 5. What do you think we put in there? Okay, whatever the output. Value. Yeah, the y value for whatever the x value we put in there. So for this one here, it'd be 2 to the power of 1, which is 2. For this one here, it'd be 2 to the power of 3, which is 8. Yep. For this one here, it'd be 2 to the power of 2, which is 4. This one would be 2 root 2, and this one would be 4 root 2. Do you see that?
Yeah.
Okay, cool. All right, now, let me show you the difference between Simpson's rule and the trapezoidal rule. Okay, there's a slight difference. Okay. The trapezoidal rule has a specific formula. The trapezoidal rule has h on 2, right? Value 1 plus 2 lots of value 2 plus value 3. Okay? And that is the approximation of the area. That's the trap rule. Now, before you run and jump and say, ask me any questions, right? I've done this for 3 function values, not for 5 function values, right? So our function values are v1, v2, and v3, which will be 2 root 2, 2 root 2, and 4. Does that make sense?
Yeah.
Okay. And h will be the gap between them. Okay?
Okay.
So h would be 0.5. Does that make sense?
Yeah.
So that's the trapezoidal rule. Okay? So to do 5 function values, you basically add another string of 3. So you got h on 2, and in this situation, you're starting from the v3 again and going to v5. Got it? So you got v3 plus 2 lots of v4 plus v5. Got it?
Yeah.
Yep. And then you plug in the answer, plug in the values, right? So you got 0.5 over 2 plus, right? And in this case, it'll be 2 plus 4 root 2, because we're doubling the middle term, okay? Plus 4 plus 0.5 on 2, 4 plus double the middle term, 8 root 2 plus 8. Got it?
Yeah.
Yep. That's the trapezoidal rule for 5 function values.
Simplify it?
Yeah, and then you simplify it.
Oh, okay.
Yep. Got it?
Yep.
Okay, so I'll let you do the simplifying, right?
Okay.
Okay, so that's the trapezoidal rule. Okay? Now, for the Simpsons rule, it is very, very similar. The rule is, instead of h on 2, it's h on 3. Got it? V1 plus 4 V2 plus V3. Got it? That's Simpsons rule. That's for three function values. Okay? What do you think we do for 5 function values?
Plus h over 3.
Yep.
V4 plus,
Not V4.
V3.
V3. Yep. Plus.
Plus 4V4
Yes.
plus V5.
Yep. Got it?
So, like, what is 5 function values?
They're your 5 function values.
So, like, is it always 5 functions?
V1, V2, V3, V4, V5. Got it? They're your 5 function values.
Can it be like 3 functions or like
Yes.
4 functions?
Yep.
Okay.
No, it'll always be an odd number.
Okay.
Okay? It'll always be an
Yep.
odd number. So it'll always be either, say, 3 function values or 5 function values or 7 function values. Does that make sense?
Yeah.
Yep. The other way that they can ask you this question is, instead of saying values, they can say strips. Right? They can ask you in strips. In which case it'll be an even number, not an odd number, when they talk about strips. Right? So basically, in this situation, 5 function values is the same as 4 strips. Right? 4 strips. Because basically, you might have a curve that looks like that, and you're starting at 1, and you're going to 3. Yep. And then you're going middle 2, 1, 1.5, and then you got 2.5. Got it? How
Yeah.
many strips do you have? You have 1 strip, 2 strips, 3 strips, and 4 strips. Do you see that?
Yeah.
But you actually have 1 function value, 2 function values, 3 function values, 4 function values, and 5 function values.
Yeah.
Okay? So just watch the wording, right? Because sometimes the wording will say, using 5 function values, work out an approximation using Simpson's rule, right? In other situations, they might say, using 4 function values. Sorry, not 4 function values. 4 strips, right? Work out an approximation using Simpson's rule or the trapezoidal rule. Does that make sense?
Yeah.
Yeah. So just watch the wording, right? The other thing that you need to watch for is they might use the word application. Okay, 1 application, or 2 applications, or whatever it is, right? Okay. Now, how many times have we applied the rule? 1, 2. Does that make sense? So 2 applications of Simpson's rule is the same as 5 function values. Got it?
Yeah.
So this is your first application, this is your second application. Got it?
Yeah.
So yeah, that's another way that they can ask it.
Okay.
So there are all the different ways that they can ask you how to do that question. But the big mistake, right, is don't, don't integrate, just use a table of values of what you already have. Got it?
Okay.
So, can I get you to try this one very quickly?
Sure.
And what they're asking for is 3 function values, right? So using the word application and using the word strip, what are they actually? What's another way that they could have asked the question?
Use Simpson's rule with 2 strips.
2 strips, or using the word application.
2 applications.
No, 1 application.
1 application.
Yeah. Okay. So do you want me to write the formula up again? There you go. That's the formula. We have the formula.
Yeah.
Where's the question? That's the question there, right? Have a go at that. There you go. Whoops. There. Have a go.
I got 88 over 27.
You got what? 88 over 20 over 27?
Over 27.
Okay, let's have a look. So, I've got no doubt you've got the right answer. So let me have a look at the table and X, Y, right? Cool.
Yep.
And then you've got X, which is equal to 0, 2, and 1. It'll be 4 over 9. Is that right? And then 4 over 3. Is that correct?
Yep.
Yep. And so you've got h over 3. So the area is approximately equal to 1 over 3 because the gap between them is your h. That's your h.
Yep.
Yep. Times 4 plus 4 lots of the middle term, which is 16 on 3, plus 4 lots of 9. Is that right?
Yep.
And is that what you got?
Yes.
Yep. And then you worked it out, and what did you get?
88 over 27.
88 over 27. Good. Perfect. Was that hard?
No.
Right. That's Simpson's rule. When you do more than one application, right, what I want you to notice is, and this is how they'll teach you at school, right? Or this is how Margaret Groves will teach it to you, right? If there's more than one application, they'll teach it to you like this, which is h over 3, right? V1 plus 4 lots of V2 plus 2 lots of V3 plus 4 lots of V4 plus 2 lots of V5 plus... Does that make sense? Do you see what I'm doing? 4 lots of V6 plus dot dot dot, whatever your last one is, V7. You see what's going on? It goes 4, 2, 4, 2, 4, 2, whatever. Do you see what's happening? And the reason why is every application, this term and this term are the same. Yep. And when you add them, what happens to them?
They become 2.
2. Yeah. Yeah. So it becomes 4, 2, 4, 2, 4, 2. They alternate. Got it?
Okay. Yep.
So the way Margaret Groves teaches it is, right, or the textbook teaches it, is first term plus last term, 4 of every middle term, and then 2 of every alternate middle term. Does that make sense?
Yeah.
4, 2, 4, 2, 4, 2, right?
Okay.
In terms of the trapezoidal rule, it'll just be easier. H on 2, V1 plus 2 lots of everything in between, the sum of everything in between, plus V, whatever the last term is. Got it?
Yeah.
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 Yeah. So just remember that, and you should be right.